Okay, so the first two questions that we will do will be exam style questions that you will probably see. So this first question, it gives you 2 points on a quadratic. So it says the points A, which the coordinate would be 0, 45, and B, 12, 45, lie on the graph of a quadratic function. What is the equation of the axis of symmetry? So 0, 45, and 12, 45. They're going to give you ridiculous y values, but they're going to be the same y value. So here's what I sort of want you to think of. If we were to do just a rough sketch of this, so 0, 45 is a y-intercept. So I'm going to make this line 45. 0, 45 would be right here. Then 12, 45, let's put 12 over here, and 1245 would be on the same line. And it says these 2 points lie on a quadratic. It's really hard to visualize what the equation of the axis of symmetry would be, though some of you might be able to actually do that from here. But what I'm going to draw is I'm going to show you there's many different quadratics that we could look at. So the key is that these 2 points have the same y value. So let me just draw a quadratic going down like this, and then it might help you to see if you could figure out what the equation of the axis of symmetry would be. Does anybody know? Raise your hand if you think you know. I just want to see. So Tessa, Marco, Jevin, Jesse. Tessa, what do you think it is? It's x equals 6. If these two have the same y value, then the middle of 0 and 12, the middle would be 6. So the equation of the axis of symmetry would be x is equal to 6. So halfway between 0 and 12 is 6. Now, what if I gave you coordinates like this one? So just write these 2 coordinates down. 2, 95 and 22, 95. Raise your hand if you know what the equation of the axis of symmetry of these 2 points would be. And then I'll show you the math. Like the other one was really easy to see because you know halfway between 0 and 12 is 6. This one's a little bit not as easy to see, but there's simple math that you could do. Jevin, what do you think this would be? How'd you get that? Okay, so actually there's a couple ways we could do this. So if we had 2, 95, so 2, 95, so let's say it was that guy, and we had 22, 95. Okay, so my axis of symmetry, it's dividing these 2 in half. So the math that you could do is you could do 2 plus 22 and then divide that number in half. So 2 plus 22 is 24. 24 divided by 2 is equal to 12. Okay, so x is equal to 12. Is that how you did it, sort of, or how did you do it? Oh, okay, you did even more complicated. To me, this is the easiest. You just take your 2 x coordinates, add them together, divide it by 2. That will give you the average, right? So if I said, for example, if we had x coordinates of 4, 100, and 16, 100, what would the equation of the axis of symmetry for this be? It'd be 10. Yep, because 4 plus 16 is 20. 20 divided by 2 is 10. Yes. Okay, take a minute to write this down. This is what a long answer is going to look like. And we need to talk about this word compare. We would have done compare in 10C, and it would have been on your final exam in 10C. You had a compare question. Your diploma next semester is going to have they always have a compare question on the diploma. And so we put a compare question on this exam. It's a long answer, it'd be worth 5 marks. So just write these two quadratic functions. So f of x is equal to negative 5x squared plus 3. And this guy, g of x, is negative 5, x plus 2 squared plus 3. It's going to say the word compare, and it specifically wants you to talk about, we'll add domain to this as well. So I'll show you how I would set this question up. Okay, so what I would do is I would divide this question in sort of 3 parts. So we're going to have the first function. We're going to have the second function. We're going to have the word compare. And we'll talk about what that means mathematically. And then what we are comparing is we're going to do vertex. We're going to do domain, range, opening, translation, and axis of symmetry. So we're going to compare these 1, 2, 3, 4, 5, 6 characteristics. Does anybody remember in 10C what the word compare means? When students do compare, they often think it's talking about the similarities, how two graphs are going to be similar, and you wouldn't get marks because you're missing half of something. Does anybody remember what it would be? When you talk about the word compare mathematically, you have to say, talk about the similarities and differences. So are the two graphs, is the characteristic between the two graphs similar, or is it a difference? So for example, I'll do the easiest one first. Let's look at the opening of both of these graphs. So Hans, this graph and this graph, what would the opening be? Does it open up or down? Down. Okay, so the A value is negative 5 for both of these. It wants us to talk about the opening, so both will open down. Are they going to be similar or different? This would be a similarity. Both graphs will open down. That's a similarity. So you have to say exactly what they want. They want the numerical value. So A was negative 5. You're describing it opens down because it's the same. It's a similarity. Okay, the vertex. This one's nice and easy because it's in vertex form. Steve, what's the vertex of this first guy? Okay, so the vertex is 2, 3. Does anybody know what the vertex of this would be? Yes, this guy would be 0, 3. Now, if you were unsure about that, you are just punching it into your calculator. Okay, so you're punching in negative 5x squared That's the A value, which is going to tell it to open down. This is the Q value right here. That's the Q value. There's no P value. So if I graph this, zoom 6, this is what this graph would look like. So this graph here, the vertex is at 0. Oh, what did I? Negative 5x squared plus 3. No. So it's going up 3, but it's opening down. So 0, comma 3. Okay. Do these have similar or different vertexes? They're different. If you wanted to, you could put the other graph in y2. What is the domain of both of these graphs going to be? Chris? Domain of both parabolas will be what? Negative infinity to positive infinity. Sophie, is that a similarity or a difference? That's okay. The range. The range of this first guy, what would the range of this be? Jack, what's the range of this graph? Yes. Okay, round bracket, negative infinity, comma 3, square bracket. This next one, if we were to do a little tiny sketch of this guy, we said the vertex was at 2, comma 3. And this guy opened where? Down. Okay, Drew, what's the range of this function here? Negative infinity, 3, square bracket. Similar or difference, Drew? Similar. Okay, translations. This one only has one translation. Jevin, what was the translation for this one? 3 units. Is it vertical or horizontal, would you say, on a test? Vertical. So you'd have to write Q is equal to 3. Don't write VT on a test, right? Vertical translation, 3 units up. This one is, again, Q is equal to 3. Vertical translation, 3 units up. But this one has another translation. Dawson, what's the other translation for this guy? Yes. So P is equal to 2. Horizontal translation, 2 units right. Okay, so you'd say, Isaiah, well, how would you compare the translations? What would you say? Similar what? Different what? Yes. So similar, vertical translation, different, horizontal translation. Okay, axis of symmetry. Tessa, what's the axis of symmetry of this guy? What's x equals 0? Brody, what's the axis of symmetry for this guy? No, it's x equals 2. Yep. Remember, it comes from this guy here. And then, Benita, similar or different? Different. Everybody's good for that? It'd be a 5-mark long answer question based on whatever your two functions are. Yes. It will tell you what it wants you to compare. So you compare whatever it lists. Okay. Oh, you know what sorry, you know what I missed, which is actually important? Stretch, because some of you will get the stretch wrong. So let's write stretch. Okay. They both have vertical stretches. Stretch factor of. Some of you are going to get the stretch factor wrong on the test. Do you remember what it is? Vertical stretch, stretch factor of, what's a stretch factor? It's 5. Yeah. So any of you that put -5 would get vertical stretch, stretch factor of 5. Remember the stretch factor? The A value, if it's negative, it's going to talk about a reflection. So there's a vertical reflection in the x-axis if it asked. But the stretch, you never say a stretch factor of -5. You just say a stretch factor of 5. Yes. What's that? I think this is probably the easiest way to format it, but if you have a different way that you're writing everything and comparing it numerically and then writing similar or different, then it could be whichever way you want. I think a chart's always easiest for similarity questions, though. Okay, let's do a new type of question. Yes. Yes. Yep, as long as you have a... Yeah. Okay, so write this guy down. Two numbers have a sum of 36. What is their product if it's a maximum? Okay, so here's what I mean by this. You could just watch up here for how I'm going to explain the question, but then I'll show you mathematically how we would solve this. Two numbers have a sum of 36. I'm going to give you guys two numbers that sum to 36. Do you agree that that would sum to 36? If I multiply, product means multiply. If I multiply 30 times 6, what would that answer be? 180. Okay, what I'm basically trying to find out is what two numbers would sum to 36 that would give you the biggest product that we could have. So for example, I'm going to give you another two numbers, 34 and 2. That sums to 36. But 34 times 2, what would that be equal to? 68. So there's two numbers that will sum to 36 that will give you, I want the biggest product possible. Yes. What's that? Okay, I'm going to show you how to do it mathematically if this was a long answer question. Okay, so here's the thing. We're going to create two different equations. And the first equation is going to have to do with this sentence here. Two numbers have a sum of 36. So x plus y equals 36. So two different numbers have a sum of 36. The product of the two numbers will be my second equation. So do you guys know what the second equation would be? For what's product of these two numbers? So sum is x plus y, and if I want the product of those two numbers, it's x times y is equal to, what I'm looking for is the max product. Okay, so we're going to do something we did in grade 10, and it was called a systems of equations. And there's going to be a whole unit in 20-1 on systems of equations. So what we do is I want to go to this first system, and we're always, if we can, we're going to solve for y. So write down solve for y. So rearrange this system. A system, you guys, is just an equation. Rearrange this system to solve for y. So what that means is minus x minus x. Y is equal to 36 minus x. What we did with systems of equations is you solved for one of the letters in the first equation. And do you remember where you put this? So y is equal to 36 minus x. You're going to take this guy out, and we're going to input 36 minus x. So y is equal to 36 minus x. We're going to take this y out, and you're going to put in 36 minus x. So I've got x times 36 minus x. Let's expand this. And we're going to get 36x minus x squared. Let's rewrite this in descending order of x. So let's just rewrite this like negative x squared first plus 36x. And then I want you to complete the square. So we don't have a c value, which is fine, but put your bracket here. Remember the c value is normally on the outside of the bracket. What do I have to factor out from here? A negative 1. Because remember, in order to complete the square, I need a 1 in front of my x squared. So factor out your negative 1. Negative 1 comes out, and you're going to have x squared minus 36x. Leave yourself some space. Go to the 36 and create your magic number. So what would my magic number be? What's 36 divided by 2? Positive or negative? Negative 18. Square that. Does anybody have negative 18 squared? 324. Minus 324. Times that by what number? Negative 1. Okay, that's going to give us plus 324. And you're going to have an x here. So just write it like this. This graph has a vertex at 18, comma 324. This is your x value. And with these questions, this y value is always the max that you were looking for. So let's see what this means. The x value would be 18. Okay, so the x number is 18. What's the y number? 18. So here's our equation. We'll do a second one of these just because a lot of you will be like, oh my God, what was she doing? 36 minus, if x is 18, 36 minus 18, y is also 18. Those are my two numbers, 18 and 18. 18 and 18 will sum to 36. And if you multiply 18 and 18 together, what product does it give you? It gives you 324. So the two numbers are 18 and 18, and the max product that you could get is 324. Okay, I'm going to show you, we're going to do this exact same question. You will be able to look at it and tell me what the answer is, but would you be able to complete the square? So here's the last one we'll do. This one. Two numbers have a sum, because then what's going to happen tomorrow is I'm going to show you a different style question that you won't be able to look at it. Okay, so you have to understand how to set this up. Two numbers have a sum of 28. What is their product if it's a maximum? Raise your hand if you know what the two numbers are based on the last question. It's going to be 14 and 14. 14 and 14 will add to 28, and it's going to give us the biggest product that exists. How we get it, though, is we're going to have to create what's called a systems of equations. We can get two different equations from here. So two numbers have a sum of 28. Scarlett, what would that equation be? Two different numbers, sum. Yes. So first equation, x plus y equals 28. Second system, a system is just another word for an equation. What is their product if it's a maximum? So product means take those two numbers and multiply them together. So my second equation is x times y is equal to, what we're looking for is a max product. This is the equation that I don't change because I'm looking for the max product. So this is the equation that I don't manipulate. You go over to here. This is the equation that we'll manipulate. If you have a y, you always solve for y. So if I solve for y, solve for y, Hans, what would my first system be if I write it in the form of y is equal to 28? I just want to get y by itself, so get rid of this x minus x. Okay, systems of equations means you solve for a letter, and I just solve for y. So over here, that's what I just solved for. We're going to take what we say y is equal to, and we're going to input it into here. It's a method called substitution. So I've got x times y, and y I said is 28 minus x. And that's going to equal this max product. Expand your quadratic, and you're going to get 28x minus x squared. Rewrite in descending order of x so that you can complete the square. So we don't have a q value, which is fine. Sophie, what do I do from here? Divide out what, sorry? Bring out the negative 1. So factor out the negative 1. Jesse, what do I do from here? Okay. Amelia, from here? What's 14 squared? Okay, so add 196 minus 196 times my negative 1. Okay, this is going to give you plus 196. We're going to have a negative 1 here, and we're going to have an x here. The answer is going to be in the vertex. Well, part of your answer. That would be 14 and 196. This was our x value, and this 196 is the max product. How you would get the y value, you guys all know that y is going to be 14, but what you would do is you would take that x and you'd put it into this equation here. So y is equal to 28 minus 14. Y is equal to 14. So you'd have to write a sentence, and your sentence would be the two numbers are 14 and 14. And when you multiply 14 times 14, you would get the maximum product that you can, which would be 196. Are you good with that?